Today we're going to be looking at the 2015 February Silver question, Superbull. So in this question, Bessie is basically looking at a bunch of hoofball games, and she's playing a bunch of matches against the other cows. Every time they play a match, one of them is eliminated. So the question is asking for the maximum number of possible points that can be stored. So there are a couple of clues that tell us which algorithm we should use for this question. The first one is, for every game, we know that we are going to eliminate one team. We also know that we want to have one team in the end. So if we have n teams total competing, and we want to have one team left in the end, that means we're going to have to eliminate n-1 teams, or play n-1 games. So in a fully connected graph with n-1 edges, that's going to be a tree. We also want to find the maximum possible number of points, so we're going to be using the algorithm MST, or maximum spanning tree. So in this case, our tree is going to have the cows or the teams as the nodes, and then the games as the edges. So if cow 1 and 2 play a game that has points 3, then we're going to have cow 1 and 2, the nodes, be connected by an edge of 3. So with MST, there are two main algorithms that we could use, Kruskal's or Prim's. And the main difference between the two is the more edges you have, the more likely you are to use Prim's, because with Kruskal's, you have to create all of the edges beforehand, while with Prim's, you just use on demand. So while I use my priority queue or while I program, I'm going to look for the edges. In this case, we don't have a direct perfect tree. We need to find all of the edges. So for every node that I'm currently on, I need to look at every single other node to try and find the one with the best value. So we're going to have around n square edges that we need to find and pick the best ones of. So in this case, we're going to use Prim's. For the algorithm, we're going to be using a priority queue, and now we're going to look through the pseudocode. So while the priority queue is not empty, we're going to pop the first value, and then, like I said earlier, we're going to look at all of the other edges, and then we're going to calculate the amount of points, and we can just create a function above to look for that. And then we're going to say, if this point is not yet visited, we're going to push it into the priority queue. So again, since we have to look through all of the other edges and calculate the best ones, we are going to use Prim's. So let's move on to the actual code now. So the first thing we're going to do is we're going to make our data structures. So we're going to have a visited array, and we're going to have an array for the nodes. And then we're going to resize them down here. Then we're going to read in the input. So the input is pretty standard. And now we're going to move on to the actual algorithm. So again, the main data structure we'll be using is going to be the priority queue, and in the beginning we are just going to have two main values for our priority queue. So we're going to store a pair. The first value is going to be the current amount of points or distance, and then the second value is going to be the index of the node. It doesn't really matter which node we start on, so I'm just going to start on with 0. So then we're going to say, just like in our pseudocode, while the priority queue is not empty, we are going to pop, and then we are going to check if it's visited. So then we're going to add to our answer. So then we're going to add to our answer and then mark that it's visited. Down here, this is again just like in the pseudocode. We're simply just going to loop through all of the other values. We're going to check if it's already been visited, and then if it hasn't been visited, we're going to find the number of points. So we're going to find the value of the edge, and then we're just going to push it in. And that's pretty much the base of the program. At the end, we are going to output our answer, and then over here, this here is going to be our points function, and all this is going to do is calculate the number of points. So the problem states we're going to use the XOR, and in C++, this is the XOR function. And then that's our entire program.